In this video, we're going to take a look at an introduction to discrete random variables. Now, in A-Level Maths, you will have taken a brief look at discrete random variables, but in A-Level Further Maths, we take this now to another level, and essentially we're looking now at the applications of discrete random variables and why they are so useful. So, in this video, we're just going to give a brief introduction here, and on the next page, there's an example question that we'll work through, and then a practice question for you to have a go at. So, to start with, let's just give the definition of a discrete random variable. Now, a discrete random variable represents the number of distinct values that can be counted of an event. So a really kind of common example of this, or quite a famous example, is rolling a fair six-sided dice. So what we say here is x, and this is usually the letter we use here to represent a discrete random variable. So capital X here is the uppermost face of rolling a fair six-sided dice. So if you imagine you're looking down at a table here, we roll a dice, whatever face is on top, that's the value of our random variable x. Okay, so we represent this now as a probability distribution. So this is usually in the form of a table here. So what I've got is x, little x here, and this represents the face. So that would be in this case 1, 2, 3, 4, 5, and 6. So let's just mark this off here. And then underneath what we've got is we have our probability of our random variable being equal to the values. Okay. Now, obviously the probability of getting a 1, that would be 1 out of 6. Like we said, this is for a fair six-sided dice. So that would be 1 out of 6. Just mark this off here. For a 2, that will also be 1 out of 6. For a 3, again, will be 1 out of 6. And you can see the pattern here. They're all going to be 1 out of 6. So we'll just mark this down here. And it's important to know here, this is actually a special distribution. This is what we call a uniform distribution. So this is a uniform distribution. So let's just write this down first. And a uniform distribution here simply means that for each outcome, so each face of the dice here, so 1, 2, 3, 4, 5, and 6, the probability of getting that face is equally likely. So the probability of getting a 1 is equally likely as getting the probability of a 3 here. Same for 5, 4, 6, and a 2. So they're all equally likely. So like we said, this is a uniform distribution. And hopefully it's pretty clear from our probability distribution here that for the probabilities, the sum of these probabilities should add to 1. So if we give this in notation, we're saying the sum of the probabilities for our random variable being equal to the outcomes here, this is going to be equal to 1. Okay, and this is quite an important result here. We will use this pretty much through every video that we do on discrete random variables. Okay, so I think that gives us everything we need now to kind of jump into discrete random variables. Like I said, it is a very brief introduction, but that should hopefully serve us for now. So there's an example question here that we're going to work through together, and then on the next page, there's a practice question for you to have a go at. So what we've got here is a discrete random variable x. Again, notice we use this capital letter notation, and it has this probability function. Okay, so we've got it in the form of a table, and we're asked to find the value of a. So notice a here is this last probability of getting a 4. Now, context-wise, we don't actually know what this probability function represents, but we're just looking for this probability. Okay, so we use the fact that the sum of these probabilities, so the probability of our random variable being equal to little x, is equal to 1. Okay, we're going to use this idea. So what I can say then is 0.1 plus 0.3 plus 0.05 plus 0.3 plus a is equal to 1. Okay, that's what we've said here. The sum of the probabilities is equal to 1. So all I've simply done here is added all these probabilities and set them equal to 1. Now in this case, we can easily solve for a now. All I need to do is add everything on the left-hand side together, and then we're going to subtract from 1. So what I've got here is 0.4, 0.1 plus 0.3, 0.4, plus 0.3 is 0.7 plus another 0.05. So I get 0.75 plus a is equal to 1. So in that case, we can simply solve for a here by subtracting 0.75 off both sides, which would give me 0.25 there. Okay, so a is equal to 0.25. And like you can see, these questions are quite straightforward. This isn't really expected to be difficult. But usually, when you take a look at exam style questions, they will usually begin in a way similar to this, or what you're going to see on the next question. Okay, so it is important that we do understand the very basics of discrete random variables. So we've worked through one example together, now it's your turn. So what I'd say here is pause the video, have a quick go at this practice question, and then we'll take a look in a moment at how we do this question. So hopefully you got an okay with this practice question. Let's take a look now at how we should have done this. So I've got another discrete random variable x here, and we've got our probability distribution. Now in this case, we can get the events 1, 2, 3, and 4. Again, we don't have any context, so we can't really contextualize this problem. But I've got my probabilities. So we've got the probability of k for x being 1, 3k for x being 2, 5k for x being 3, and then 7k for x being 4. Now what I want to do here is show that k is equal to 1 over 16. So where do we get this 1 over 16 from? Okay, at this point it kind of looks like it's just been plucked out of nowhere, but we can use the fact that the sum of the probabilities for our random variable here are equal to 1. Okay, so in that case, what we're saying then is k plus 3k plus 5k plus 7k is equal to 1. So if we do that, so k plus 3k plus 5k plus 7k, this is equal to 1 now. Okay, so all I need to do now is simplify the left hand side here. So that's 4k plus 5k is 9k plus 7k gives me 16k, and this is equal to 1. And hopefully it's clear what we need to do now. We just divide by 16, so therefore k is equal to 1 over 16 as required. Okay, and there we have it. So like you can see, nothing too tricky. We're using generally this idea to start with to get us started really with our introduction to discrete random variables. So that brings us to the end of this video. In the next video, we're going to take a look at finding the expected value of a discrete random variable.